Hey everyone, welcome back to 197 Concepts. Today I'm going to discuss with you how to make an LED blink with the Arduino board. I believe you are familiar with the Arduino board. Arduino is a very commonly used motherboard with a pair of microcontroller in order to control the LEDs or any other sensor or anything else. You can call it as an embedded system. Okay, so basically we are going to see how to control uh, an LED using the Arduino board, a basic type of embedded system, you can say that. But before going to that part, I will be explaining you the program that is needed for controlling the Arduino board. Okay, because directly you cannot control the Arduino board, but you can program it, and from that you can control the sensors. So indirectly or control in order to control the sensors, you have to control the Arduino board, and for that you have to type a program. So in this video, I will be explaining you how I will be explaining you how program is going to matter while controlling the LED. We will just make it blink for some duration, and we will make it turn it off. That means we will turn it on and turn it off. Okay, that's the meaning of blinking. So first of all, let us start with the program. See here, this is the program, and in order to know what is an Arduino board, I will show it in the next video while I will be doing the circuit diagram. Up to this video, I'm going to discuss only about the program. Okay, so this is the program. So you can see here that I'm having two parts: this user-defined pin and a default pin. Okay, so be clear that the Arduino board is having a built-in pin for testing the blinking of LED. For any troubleshooting, whether the Arduino board is responding or not, you can simply dump 3 to 4 lines of program, and then you can check whether the Arduino board is responding to your input pro code or not. So for that, we are having a default built-in pin, whereas you can also use a user-defined pin. That is your wish, which pin that would be. Okay. So while connecting the circuit, I will show you the difference between the default pin and the user-defined pin. Up to now, just keep in mind that you're having two ways for testing or for testing the LED with the Arduino board. Either you can use the default pin or you can use the user-defined pin. There is no doubt in that. Okay. And now, if you compare the both the programs, the user, let me maximize this. Okay, so if you compare the default pin and the user defined pin programs, there is nothing but there is no difference. Just this LED built-in and the LED name difference. Okay, that's the only difference. If you compare this void loop, if you compare this void loop, it's the same. Only the names are going to change. Okay. So now let's coming to the program. It's a very simple program. There is nothing complex here. Okay. So this one, void setup and void loop. Basically, Arduino program is going to have two sections where you are going to set up your Arduino board and you are going to make a loop run. That's what we are calling void loop and void setup. These two words I will define more clearly when I open the IDE software of Arduino. Okay, so just remember that every Arduino program, every program that you are typing to control the Arduino board is having two sections. One is the void setup and the other is void loop. Okay, so these braces are important. Keep in mind this is a case sensitive language. Case sensitive language. Okay, that means digital let, or else we take the command pin mode. This and pin mode. Observe the M here. This is the capital one and this is the small m. Okay. These two are different commands. This is not recognizable by the software. This is recognizable. Okay. In its memory, pin mode, mode with capital M is recognizable and it is a command used in Arduino IDE. Whereas if you type it with WM, sorry, small m, you won't be able to the program will won't be able to recognize this code. So I will show you this when I'm typing the code. Okay. And when you come, so in the setup, you are just writing LED built-in and output. Here, what you are doing is the pin mode. This command tells you what is the mode of the pin. Okay, so for basically, you have to know the basics of our what we say Arduino board. So just for a rough reference, let us assume that this is a board. Okay, this is Arduino board. I'm writing AB, and this is having 40 pins. This side 20 and this side 20. So this side will be 20 pins, and these side will be 20 pins. Not necessarily it should be in the same manner. When you go for different packages in the Protea software, you'll get different things. But when you come for the hardware implementation, definitely those will be equal on both sides. Now, for example, let us assume that this pin, the first one pin, this is the pin number 11, because we are taking the example of 11 in the notepad, use a defined pin. Okay. Now, after taking this pin, now you have to be clear that these 40 pins, this side 20 and this side 20, these 40 pins are input and output pins. So these 40 pins can be used as input as well as output. Now you might be familiar with input and output. So if these 20 and these 20 pins I'm using as input, this Arduino board is going to accept the signals from the external world. Okay, so from the external world, it is going to accept the signals. Now, if I am using this 40 pins at out as an output pins, then those pins will be used by the Arduino board to send the signals out of it in the external world. Okay, so that's the difference between IO pins, input and output pins. For example, I'm connecting. Let us take the example of our LED itself. I'm taking an Arduino board and I'm having say 20 pins, and here I'm having 20 pins. Out of this 20 pins, this first pin is considered as 11th pin, and to this pin, let me change the color, black green. Yeah, this will be much better. So to this 11th pin, I'm connecting an LED. Okay. Of course, when you go for the practical implementation, definitely you have to keep a resistor here, or else resistor is not needed, because this Arduino board by default will give an output voltage of 5 volts itself. It's going to take 5 volts as an input, and it is going to give 5 volts as an output also. So there is no need for a resistor to be placed between the Arduino board and LED, but it's up to you. You can keep it. Okay. So this is the setup of our experiment, a diagrammatic representation. Okay. Now I have to tell this Arduino board that out of these 40 pins, the 11th pin is the output pin. Otherwise, the Arduino board won't be able to understand whether it has to give the signals out towards the external environment or to accept the signals from the external environment. Okay, so if it is accepting signals from the external environment, then that particular pin will be considered as input pin. And if it is sending, or if it is using a particular pin to send the signals outside of it, okay, that means it is sending the signals to the external world, then that particular pin is called as output pin. That's what we are defining here in the pin in the program code with the help of the command pin mode. Okay, so in the further experiments, we will be using some particular pins as input pins also. There you will get a more clarification. But up to now, you have to know what is the function of the pin mode command. So this pin mode command, it will be telling the Arduino board that a specific pin is input or output. That's the main thing of this pin mode command in the Arduino IDE. The next most important command is digital write and delay. That's the three commands that you're going to use in this program. Okay. So the next one, I will start with the delay. Okay. Delay is a very simple command. The name itself tells that it is going to create some delay. So be mindful, it's going to calculate the delay it's going to calculate the time. So basically it's going to work as a counter. Okay, so that counting will be carried in milliseconds. Okay, so now 1000 milliseconds, you might have observed there, I have written as delay of 1000. So I believe 1000 milliseconds equals to 1 second. That means when I execute this program into the physical setup or virtual setup of the experiment, I will be having 1 second time of LED turned on and 1 second time of LED turned off. Okay, so that I will show you when I'm going for experimental setup or when I'm going for virtual experiment. That will be in the next video. Up to now, you just keep in mind that delay is nothing but it's a counter uh, that keeps a track of time for your for carrying out a specific function. Okay, so that's the meaning of delay. And then the next very most commonly used command is digital, right? So here the W should be capital and here the M should be capital. That's the main thing. If you write a small w here, the Arduino program won't be able to recognize this command. It will say something else. The specified command is not in my memory. It's not in my header files and all and all. Okay, so definitely you will get an error. That's the main meaning. So you have to write capital W in digital write and capital M in pin mode. And the meaning of this command, digital write, it means that okay, you are defining pin number 11 as an output pin, but you have to send logic 1 or logic 0. All these 40 pins will be digital pins. Okay, keep that in mind. Out of these 40 pins, you will be having around 10 or less than 10 pins, like 6 or 7 pins as analog pins. Okay, what is the purpose of these analog pins? See, basically Arduino board is a digital circuit. It can understand only the language of logic ones. It can understand only the language of logic 1 and logic 0. Now in some cases we will be having analog sensors to connect to the Arduino board. For that particular cases we need converters, analog to digital converters, in order to convert the received analog signal from the sensor into the digital signal. What is the main purpose? Because Arduino board is able to understand only the digital logic. Okay, it is not able to understand the analog logic. So for that, 6 to 7 pins or less than 10, you can consider 10 pins or less than 10 pins. These 10 pins, roughly 10 pins, are in analog mode, but you can use those 10 pins for digital purposes also. There is no doubt in that. Okay, so the digital write is going to tell you what at what period of time or at what specific moment you have to send as a logic 1 or logic 0 onto that particular pin. That's the main thing of the command digital write. Okay, now when you come to this code, what you are going to do here is, yeah, this one is there. Let me delete this. So what you are going to do here is, you are first of all you are telling a system to keep to make a startup with to make a startup, defining what particular pin is going to be as an output or input. Then you are asking that particular pin here, the defined pin here, LED built in, that defined pin has to be high or low. So high, HIGH. Be careful, this should be capital. Output high, low, this should be capital itself. LED built-in, it's a user-defined name. It can change according to your need. So LED built-in is a command so that defines pin number 13. Pin 13. So this can be accessed with the name LED built-in. So I'm writing in small also, but it should be typed in caps lock itself, because only that way the Arduino IDE can be recognizing this particular pin number 13. Okay, so you can go in this way also, but it's additional one line extra. Okay, for reducing this one line, we are using pin number 13 instead of pin number 13. We are using LED built-in. Underscore is very important. It's a complete one word. So whatever you are going to define here, it's going to be placed here. So if I say, for example, if I wrote I made a global declaration as LED or else in LED built-in UILT built-in is equals to 13. Then pin number 13 itself I can use with this name. Okay, so I can keep it LED itself or LED built in this whole name. I can redefine it, no problem. But what I'm trying to say is whatever you're going to define here or whatever you're going to define here, that should be placed here itself, digital right and all. Okay, if you don't do that, the program is going to change. So be careful of that. So you are setting up the you're initializing a circuit. So you are saying that pin number 13 has to use for LED built-in function, for LED blinking function, and that particular pin, since we are using it for the LED, it must send the signals. Arduino board must send the signals outside of itself towards the LED. That's why it is defined as output pin. Then after some time, I'm telling that you have to keep, I have to send logic 1 in order to turn on the LED. That's why I'm using the command high. So high is equals to logic 1. Then I won't I don't need this LED to be turned on for a huge amount of time. Uh, I need just 5 seconds or 1 second or 500 milliseconds and all. Here I'm keeping a delay of 1 second. Okay. So after 1 second, it should turn on in order to represent the functioning a function of blinking. That is why after 1 second, I'm writing again digital write LED built-in. LED built-in means pin number 13, and I'm turning it down because low equals to logic 0. Okay, so logic 0 means it is 0 volts. Logic 1 means it is 5 volts. That's why for high your LED will be turned on and for low your LED will be turned off. Okay, and when you come here for the user defined pin, that's it. That's the program for default pin. When you come for user defined pin, it's the same functioning. Okay, so high means you're sending logic 1, and after 1 second you're low. That means I'm sending logic 0. Okay, this means LED on, LED on, and this means LED off. Okay, so LED on and LED off. What the difference is, instead of using LED built-in, I'm using a separate pin which is pin number 11, and I have initialized it with the other name, that is small LED, all small letters, LED, LED, LED. Okay, it should be same. If I defer this, I will get an error. Okay, and this constant input is a global declaration method. You will be familiar with that. This almost, so Arduino IDE, okay, integrated development environment. So Arduino IDE is going to be the software that I'm going to use in order to execute this program, and this basically runs on embedded C. Okay, so it's a very simple program, and I will show you the execution in Arduino IDE. Okay, so just let's go and search for this. Oh yeah, here it is, Arduino IDE. So this is the Arduino IDE. Okay, and it's up to you whether you want to update or not. I'm going with this already on the existing version. Okay, so when you get this like this page, what you have to do is always go for file and new sketch. Okay, do not this is the previous what I have used, the last program that I have edited or what I have executed, that's the program. Now I need a new program, so that's why I'm turning this on. Okay, and now when you come here, basically when I come here, you are able to see here that I'm having two sections, the void setup section, the void setup section, and the void loop section. Below that, you are having a comment line also. Put your setup code here to run once and put your main code here to run repeatedly. That's why the name setup and loop. So this, whatever you are going to type here, the lines 2 and 3, if you're going to type 2 or 3 lines, the lines 2 and 3 will be executed only one throughout the 10 lines of program. Okay, after that only the loop section will be running repeatedly. That means the line from 7, 8, and 9. those three lines 7, 8, and 9 will be running continuously. That means yeah, it's like connecting your headphone sets with the phone. Okay, you are just going to turn them on once, you are not going to turn them on multiple times, right? It's the same way. You are just going to define what particular pin is going to do, whether it is an acting as an input pin or else it is acting as an output pin. That's the only thing you are going to define there. And after that, what that particular pin is going to do at what period of time, is it turning on or is it turning off, or is it accepting the data, or it is sending out the data, or it is sending a signal to the Wi-Fi, anything else, that's up to you based on your code. So basically you're having two loops, two functions, that is a setup and loop function. Okay, and setup will run only once, whereas loop will run repeatedly. I won't say the number of times, it runs repeatedly until you stop that execution, it keeps on running. Okay, that's the meaning of that. So let us copy the program from the notepad. Void setup, new sketch, paste it. Okay, so that's it. Yeah, before executing it, try to save your program somewhere as per your wish. Okay, if you don't save it, it runs, but it stores the program in your C drive. So instead of saving it on a C drive, I'm storing it at my desired location. I'm going for desktop and a new folder. Okay, LED blink. I've created a new folder on the desktop. Okay, here I'm going to create another folder, that is default. Okay, and I'm going to create another folder for better understanding, user define. Okay, so under default I'm going to change the name from sketch underscore June 3A2. I'm going to keep it as of course not user defined, default. That's it. Okay, so this will save the file. Yeah, there you go. And be careful. One way to recognize whether you have typed the program correctly or wrong is that the color coding. Okay, so every command, every keyword is going to be colored in different colors. So if you observe here, this might be not properly visible. Let me change the preferences theme. Okay, yeah. Setup is in somewhat orange color. Pin mode is a keyword. It's in orange. Okay, digital write is, it is in orange. So 1000 is a function. You can say it as a built-in, not command, a value, constants. Okay, now so constants will be represented in light blue color, whereas this keywords, the other kind of keywords, these will be, which are not the commands. These will be represented in blue colors. Okay, and if you go for digital write, you will get how you're going to use this program, how you should use that command. Okay, so you can say it as a references. Okay, and everywhere the semicolon is very important. If I remove this semicolon, okay, so there is no error. Let us do it once without the errors. So we will execute this program once, and with the errors I will show you. Okay, so this is the program, you have typed it, file, and you have saved it. And just one thing I have to show you is, one thing that I have to show you is here, new folder, LED blinking. There you go, default, default. So this is the program. Okay, there I have stored it, and now I'm going to run this program once. Okay, so for that you have to go for the sketch menu, and you have to use the verify or compile. So compiling, done compiling, there are no errors. You can use the shortcut also to verify your program. Okay, now there are no errors. For example, I have missed the semicolon here. Now see what will happen when I verify this. See, you got an error. There is no token somewhere before here. It's saying that there is one mistake. It won't tell you the mistake, because that will be a mistake or that might not be a mistake according to this software. but it will show you where the possibility of that mistake can be. So it has told me that the compilation error expected semicolon before flower bracket, closing flower bracket, colon. Okay, token. So it said me indirectly that at 10 line number 10 you have missed a semicolon. It was like this. Now I have placed a semicolon and now I am verifying this. So of course no errors. Okay. So this is just LED, built-in LED. I will show you the circuit also, but not after completing this user-defined program. Okay. So this is, you are going to verify it. That's it, no doubt. Now, if you have a hardware, you are going to connect that with your laptop, and then you are going to use this upload option. This will compile your software once, and then it will upload into the Arduino hardware. Okay, since we are not having it, we are not going to do it now. And one more thing, what you have to do is when you compile or when you verify, both are same up to this software itself. Okay, but when you go for Python and all, compiling is different, verifying is different. And when you go for the C language, it will be different. But when you come for Arduino IDE software, here verify and compile both are same, because here you will be able to see here verify is just checking the program for errors, and compiling is also doing the same thing. Okay. Now, when I compile the software, definitely it's going to create an hexadecimal file which will be used for dumping into the Arduino board. But that hexadecimal file is going to be saved somewhere in the C drive. I don't want that. Okay. Instead of that, what I'm going to do is I'm again going for the sketch menu and I'm going to use the option export compiled binary. Okay. Now uh, you might have observed that this folder, when I go for my folder where I have saved this program, the only default file was there. There was not a build folder. Okay, what happens is when I click sketch export compiled binary, is this folder is going to be created. Build folder is going to be created, and under that folder, inside that folder, you will be having your hexadecimal file. Okay, so better you enable the extensions, but be careful with the extensions, because for other files also the extensions will be enabled, and if you edit those extensions, definitely your file won't be recognizable. Okay, for example, if you want to know that your PowerPoint or PDF files are very commonly used, the PDF files will have an extension of .pdf. Okay, if you edit that to pfd also, your system won't be able to recognize this file. Okay, so be careful with the extensions. I have enabled it to show you. So that's the hexadecimal file. Instead of going somewhere in the C drive, somewhere in the documents, you just by clicking that compile export binary thing, you will be having your uh, hexadecimal file in your desired folder. Okay, so that's about the user define default pin. Now I'm going to try the user defined pin. Okay, so yeah, I've opened the new sketch, and you might be able to see here user defined is empty. Okay, I will run both this side by side. A new sketch from the notepad. I'm going to copy this part. Okay, so this constant int led equals to 11, this is the global declaration saying that the pin number 11 in Arduino IDE is used for the led. Okay, now, so that's the main purpose. This is the global declaration, nothing new. Who you might be familiar this with the programming languages. Okay, now see here the user defined. Keep observing here. I have nothing in this folder. What I'm going to do is file, save as. I'm going to keep this location. Okay. So already, so this is the document. See, uh, before saving itself, it has showed me the documents path. Okay. So by default, when you're going to create any sketch, it is going to be saved in C drive documents. Okay. Now, so instead of consuming that area, that space, we can go for our defined location. So for easy accessing, I'm keeping it in on the desktop. It's up to you. You can keep it in D drive or E drive. That's up to you. So I'm going for user defined, and I'm going to change here uh, user defined. Okay, enter. Immediately I got a folder here, user defined. When I open this, my Arduino IDE file, okay, it's available for me here. It has created newly. So yeah, my file is saved. Now what I'm going to do is I'm just going to verify it. Okay, yeah. Instead of verifying it, you can directly use the export compile binary. Keep observing here. You will get a new folder called as build. So uh, it's up to you whether you want to verify or not. You can directly do this also, export compile binary. So after completely compiling the software, the program code, what I've got is here is a build folder. Okay, and this is also same. If I'm having some errors, definitely yeah, I will show you here with led1. So what I'm going to do is I'm going to define led1. Okay. So instead of using pin number 11 every time in the program code, I'm going to use LED. Okay. But here I've defined as led1, and what I'm defined here is what inside the program I'm using is LED. Okay. Now let me verify it once. You get an error. What is that error? LED was not declared in this scope because I have defined LED1 but not LED. Okay, so that's why I'm just going back to LED and now I'm verifying it. No errors. Okay, again, now when you want to dump this into the Arduino hardware, you can just upload it. Since I have not connected any hardware right now, I will going to get an upload error command or upload error message. Okay, now so that's it. So that's the way you write a program. And since this is a very simple program, you don't need a lot of explanation. But as we go further, you will be having multiple functions, multiple commands, multiple input and output pins where you need a clear understanding. So uh, meet you in the next video. That's it for this video. Bye.